as far as which one of these you want to start with or skip or whatever?
Could we do 9?
Sure. So, what are the measure of the exterior angles of a octagon?
360 degrees.
Okay. What's the measure of each exterior angle of that octagon?
It's 45, I think.
Okay. So, do you have a calculator in front of you?
Yeah, I do.
Get one. In other words, it's 360 divided by 8. Yeah, that looks like 45. Okay, so if I were to draw a straight line right here, then I know that measurement is 45 degrees of that exterior angle.
Okay.
Okay, now let's consider the hexagon. What's the sum of the exterior angles of a hexagon?
Isn't that, oh, hexagon?
Also,
Hexagon would be, yeah.
360. Also 360. No matter what the shape, the sum of the exterior angles is always 360. Okay?
So the hexagon, it's 60 degrees.
Okay. So we have 45 degrees plus 60 degrees makes up that angle that they're calling 3x.
Okay.
See that?
So 105 divided by 3 then?
Uh-huh. 35.
So that's 35.
X, correct. Okay, let's go over to 10. What's this shape?
That's a rectangle.
Rectangle needs 90-degree angles.
All right.
They don't tell us.
It's a parallelogram for sure.
There you go. And that's the best that it is. In other words, it's definitely not a rectangle because they would tell you that those are 90 degrees if it was a rectangle. But you do have two opposite sides that are parallel and also equal. So what equations can I begin to write in order to solve for x? Now here we want to find the perimeter of ABC. So I'm going to have to solve for AB, I'm going to have to solve for BC, and I'm going to have to solve for AC.
Okay.
So how do I start off?
We could do AE is equal to DE. Set them equal to each other.
Well, not really. AE is equal to EC.
Okay.
In other words, the diagonals of a parallelogram do indeed bisect one another, but they're not equal. In other words, AC is not equal to DB. Therefore, it's unlikely that AE would be equal to DE. What AE is equal to is EC. In other words, this diagonal does bisect this diagonal. So I've got AE equal to EC, and I also have DE equals EB.
Okay.
Okay, so let's solve for x. If AE equals EC, what equation can I write?
4x minus 2 is equal to 2x plus 16.
Solve that for x. That's only one equation, one variable. We should be able to solve it for x.
So that's 2x equals 14.
Make sure you add 2.
Oh, 18.
So there's x.
X equals 9.
Okay. And let's see. We need the perimeter of ABC. Let's see.
Could you just plug it in for...
Yeah. In other words, now that we've solved for x, I think we can get everything, can't we? Almost. We can't get BC, but it's the same as AD. Okay. So let's start with AB, which is also the same as what?
AB is the same as DC.
Okay, and what's DC equal to?
DC is equal to... One second.
Plug in.
54 minus 45.
Good. So that's AB. That's the top side of that triangle.
Okay.
And BC is equal to what other measurement that they have on here?
AD.
Okay, and what's AD equal to?
31.
And finally, we have AC. And what is AC equal to?
AC is equal to BD? Well,
no,
we already have...
In other words, we now know,
AC, right?
now know 5 different measurements here. Because every one of these lines is a function of x, and we know x is 9.
Okay.
Okay. So AC is made up of what 2 segments?
4x minus 2 plus 2x plus 16.
Add those 2 together, substitute 9 for x. What do you got? You got 54 plus 14, 68.
All right.
So, or you could have just figured AE and multiplied it by 2.
Yeah.
Is that what I get? 936 minus 2 is 34, 68. Is that what I said before? So AC is equal to 68. The perimeter is 76 plus 68, 144.
All right.
What's an undecagon?
Is that 9?
I thought 9 was a nonagon.
Yeah.
Decagon is 10.
Yeah.
What is undecagon? I don't know.
Let me...
I could Google it real quick. You want me to do it?
I'm on it.
Or you got it already?
It'll be up in a second.
Okay.
Undecagon is 11-sided.
Okay.
So that one should be...
So what's the sum of the interior angles? What's the formula for it?
N minus 2 times 180.
Okay. So 11 minus 2 times 180. 9 times 180. What is it?
Yeah, it's A.
1620. Okay.
Yep.
The measure of each interior angle of an octagon is...
We did that up there, didn't we?
No, not really. We were talking about exterior angles up here.
Oh, yeah.
They want to know what each one of those is. And they meant to say a regular octagon.
So that's 135.
Well, or is it? I would say it cannot be determined because an octagon is just an 8-sided figure. And they want the measure of each interior angle. Well, we know the sum is going to be 6 times 180. So we can certainly figure out the sum of each angle of an octagon. But we can't assume that all 8 of them are the same because it would be called a regular octagon if they were.
Okay.
So I would be inclined to say D for that, unless it's a trick question. It could be just a typo where they left out the word regular. But if it's not, and you know, they don't leave it out of this. They say regular in the next one.
Yeah.
And when they're talking the sum, it doesn't matter whether it's regular or not. But if you're talking each interior angle, then it does matter. Number 3 is the measure of each exterior angle of a regular nonagon.
So, nonagon is 9.
Correct?
So, that's just 360 divided by 9?
Uh-huh.
40.
Okay. The sum of the measures of the set of exterior angles of a heptagon is the sum of...
Hepta is 7, right?
What's that?
Heptagon is 7 sides?
But when they're talking exterior angles, it doesn't matter what it is. The sum of the measures, now this is what confuses me, of the set. I guess that means of the total of exterior angles. So that's going to be 360.
Yeah.
In other words, whether it's regular heptagon or not, it's going to be 360. Okay, shall we just continue on these? I mean, half an hour, you tell me if you want to jump to something.
We can jump to the other page we were on, because the rest of this should be pretty easy.
Whoops, that's the same thing. Well, we started out. Yeah, this was the different one. Okay. Shall we do 13?
Sure.
This is one of those ones. In other words, this might take the entire 15 minutes.
Yeah.
Okay. So, what do we know about this figure right here?
It's got 2 parallel columns in it.
What kind of figure is it?
Oh, that one. That's 1, 2, 3. It's a hexagon?
Is it regular?
Yeah.
And we know that because it's showing us that there are 6 same angles. So you can't have 6 same angles without having 6 same sides. Okay?
Okay.
That's a regular hexagon. So what's angle A?
So, regular hexagon. $120.
Yeah, 720 divided by 6, which is 120. And that looks like 120. So that's what A is. They're going to let us solve this sequentially. Remember last time we had one of these, you had to just kind of start where you could start from. But it looks like they're going to let us move sequentially across this. What's B? Go ahead and write on your paper 120. You know, in other words, or label the picture.
Yeah. B should be 60.
Okay. What is this angle here? If you can see where my hand is.
That would be also 60, I think.
which makes C.
60 as well.
Okay, so now you can label C. These two lines are parallel, L and K. So what does that make D? In other words, what's the relationship between C and D?
They're alternate x.
Are they the same or are they supplementary? That's always the answer when you're dealing with parallel lines. They're either the same or they're supplementary. Okay, so what's D?
D is 120.
Okay. Now, if D is 120, let's look at E. E is this angle right here. What's E?
Okay.
What's E going to be?
60.
Okay. As this angle here is also 60. In other words, that whole angle is vertical with D. Okay, so this angle is 60. What's F?
F is 30.
Okay, because that's a right triangle.
Yep.
What is G? What kind of shape is that?
That's a pentagon.
Regular pentagon.
Yeah.
Okay. And so G would be what?
108.
Correct. H. Where is there an H? I don't see H. You see an H?
I don't.
I see lots of hash marks that look like they might be H's, but I don't see an H. Oh, there's no H over here either. It's GMP. So let's see. If that's 108, what is M?
72.
Based on...
No, actually the angle next to G is 72.
Okay. So, no, hold on. That's the same as G. Oh, this is 72. Right.
Yeah.
But that's not going to help us because we don't know what this angle here is. Well, no, I don't think I do. Okay, but we do know what this angle is. What is this angle?
That one is 108.
We know this angle here. What's this angle here?
Uh, 60 degrees.
Okay, what's this angle here?
Looks like 72.
Okay, so in this triangle we have a 60, a 72. What's this angle here?
One second.
I think it's 48. But
48, yeah.
okay, and now we know that 48 angle, that's 108. That lets us get M.
Okay.
48, or is that what we said that was 48?
Yeah.
Okay.
Yep.
And 108 is 156. That must be 24. M is 24.
Yep.
Okay, now P, how are we going to get P?
Well, we know that other side is equal to 72.
Okay, so that's 72, that's 24, and P, well, no, P is this angle right here, so what is that angle right there?
It's, one second, 72 plus 24 equals 96, so P is equal to 96. Because they're vertical angles.
Oh, now hold on. You added M to this angle to get your 96, did you not? 24 and 72. So this is 180
Oh,
minus.
yeah.
So that one's 84.
Yep.
That's what P is 84.
All right.
Okay. We got time for another one. Which one you want to do?
Can we do 14?
Yep. Okay, that's a rectangle. We're supposed to prove that ART, this triangle here, is congruent to this triangle over there.
Okay.
So, what's statement 1?
Statement 1 is just given RACT is a triangle.
It's a rectangle.
Yeah.
Okay, so that's statement 1. In other words, it's RECT is a rectangle, and the reason is given. Okay? Now, what is statement 2?
We could do RA is equal to CA.
RA is equal to CA. Okay? Because? In fact, you might as well go all the way and say both statements. RA is equal to CA and TA is equal to EA. See why? In other words, here's what I'm saying. We're saying this line segment is the same as this line segment. And we're saying this line segment is the same as this line segment. Why is that true?
Because they have angle bisectors.
The diagonals of a rectangle bisect one another. That's the reason. In other words, these two lines are diagonals, which means they bisect one another. This line bisects RC, and RC bisects TE. The fact that they're bisecting means this line segment's equal to that line segment, and this line segment's equal to that line segment. So we've got side, side. What's the third statement?
We could do RT and EC are the same.
Correct, because?
Parallel lines.
Opposite sides of a rectangle are equal.
Okay.
Okay. It's not really because they're parallel lines. In other words, parallel lines almost always have to do with solving for angles. If you're making a statement about side length, if we're talking this side is equal to that, it's not likely going to have anything to do with parallel lines. I could prove,
are those alternate sides or corresponding sides?
Well, I could have proved that that angle is equal to that angle. So I would have angles that are congruent because of the parallel lines. In other words, the other definition of a rectangle is the opposite sides are equal and parallel. So we could have used the fact that they were parallel to make this angle equal to this angle. But yours actually was a more straightforward technique, saying RT is equal to EC because opposite sides of a rectangle are equal. And now you can make the final statement. That triangle is congruent to that triangle based on what?
Side, side, side theorem?
Yeah. You also could have said that angle is equal to that angle because they're vertical angles. And then you would have had side, angle, side. So there were various ways to go with that one. You didn't even need all 5 statements.
All right.
Almost sorry we don't have time to do this one, because this is really the way I like seeing proofs. Is I like it where they give you one side of the thing. And even though they don't give you one side for all 8 statements, it's probably enough to do it. Okay, so I would try to work 15 on your own. There's not much to know about a kite. Okay, once you know something is a kite, you know that side's equal to that side, and you know this side's equal to that side. But most importantly, you know that the two diagonals form a right angle. They're perpendicular to one another, and one diagonal bisects the other one, but not vice versa. You can see that this diagonal is bisected, but this one is not. So it's the diagonal, the short diagonal, that gets bisected. Okay, and that's really all there is to know about a kite, other than it's a quadrilateral. The most important thing is the diagonals bisect one another. Or rather, the small diagonal is bisected. The diagonals are perpendicular to one another is what I meant to say.
Okay.
And it actually wants you to prove that. Wow. Oh, okay. In other words, what you're proving is theorem 818. I was going to say, gosh, if that's all we have to prove, then we can say it's a kite, therefore that perpendicular to that. 2 steps. But they want us to prove that theorem, which requires you to prove, it's probably going to require you to prove that triangle is congruent to that triangle. And since those 2 angles are going to be congruent, they have to both be 90 degrees. That proves those 2 lines are perpendicular. Okay?
Okay.
All right, Mark. I will let you go, and I will talk to you next Tuesday, I guess.
Okay. Thank you, David.
All right. Bye-bye.